You've probably seen most of the stuff that we've talked about in these videos before in your math careers. Things like inequalities and even the absolute values to an extent are things that you've witnessed before at previous math classes. This is kind of our first topic of the year that should be brand new for you guys, so I doubt you would have come across a matrix in any previous classes. A matrix is not a bad concept. It's kind of a nice change of pace, and it's going to be really helpful in tackling a chapter later on in our book. So I'm kind of doing this chapter, out of order because it'll help us down the line. But a matrix is really just a rectangular arrangement of numbers put in brackets. So I drew an example of a matrix right here. We take a bunch of numbers, put them in a rectangle, so we have 1, 2, 3, 4, 1, 2, 3, 4, put some brackets around them, and that's a matrix. The plural of matrix is matrices. So I actually wrote that out because it's something people will say like matrices. That is, like, the plural is matrices, just so you're aware. And when we're talking about a matrix, it gets kind of annoying to have to rewrite this whole thing every time we want to use it in a problem. So usually we'll use a variable. We use capital letters to represent a matrix, typically. So capital letter for matrices. So if you're using a variable, just make it a capital letter and you'll be good to go. In learning a brand new concept, you know there's going to be some vocab that goes along with it, so I've got a couple terms I want to define. First of all, if you look at a matrix going horizontally like this, each one of those in green is called a row in a matrix. So that's a row, and so is this. Going in the other direction, so if I were to go vertically in a matrix, that is going to be called a column. So for those of you that have taken chemistry, I'm pretty sure it's the same way with a periodic table, rows and columns, or think about like the column in a building goes up and down. Horizontal lines are called rows. Vertical lines, so each one of these is called a column. We have another vocab word called the dimensions of a matrix. And the dimensions is going to be a way of saying what size your matrix is. So it gives the size of the matrix. And the way we write the dimensions, it's going to be the rows, number of rows, by number of columns. So we'll get practice with that further on, but on this example, I look at my graph here, and I have 1, 2 rows. There's the first row in green, there's the second row in green. So my dimensions on this example, this is a 2 rows, by, you pronounce the little x there, by, you're not going to be multiplying or anything, it means by. I have 1, 2, 3, 4 columns. I didn't finish circling in brown there, but 3, 4. So it's a 2 by 4 matrix. That would be how you'd write the dimensions. Finally, we have the vocab word elements. And an element is going to be an individual entry or an individual number in a matrix. So individual term in the matrix. So this matrix has 8 different elements. Each one of these guys right here is an example of an element. So we have a way of referring to our different elements so we know which one we're talking about. And typically what you're going to do, whatever your capital letter is, the elements get lowercase letters. So I would put in this example a little a, and then there's going to be like a little, it's called a subscript on these. Subscript is like a little number below your variable, and it's going to be row number, column number. So there's going to be 2 numbers right below the variable. I'll show you what that means right here. My first number right there, that 8, that's going to be a, it's in the first row. So if I count my rows, it's in row number 1. It's also in the first column. So this would be a sub 11, or a sub 11. And that's going to equal 8. If I wanted this square to 17 right there, that's in the first row, second column. So that would be a sub 12 is equal to the square root of 17. And I'll do one more. Let's say I was going for this negative 5 over here. That's in the second row, 1, 2, third column. So a sub 23 is going to equal negative 5. I'm going to do a couple more examples of these. That picture's getting a little crazy there. So hopefully it'll help make more sense. Got 3 matrices written up top here, matrix B, C, and D. For each of these, I'm looking for the dimension, and for those 2 specific elements, what they're equal to. So on my first one here, matrix B is 2 rows by 2 columns. That is a 2 by 2 matrix. B sub 11 means the first row, first column. Row 1, column 1 is right there. B sub 11 is equal to 6. And B sub 21, second row, row 1, 2, first column, that's going to equal 1. On my next one here, I have 1, 2, 3 rows, so it's a 3 by only 1 column. That's a 3 by 1 matrix. C sub 31, I'm looking for my third row, first column. Third row, first column is that 108 right there. C sub 13 means the first row, third column. We don't even have that here. This doesn't exist. There is no first row, third column. Try out this last one for yourselves here, and I'll go through it momentarily. I'm looking at 3 rows by 5 columns. This is a 3 by 5 matrix. D sub 32, third row, second column is 12. D sub 25, second row, fifth column is going to be 10.